Okay, we're doing the chapter 3.5, 6, and 4.1. So what is the domain of 1 over x? Let me move this. Okay, 1 over x. Oh, I here already have it, 1 over x. The domain meaning the value of x, what it can be, what it cannot be. We know that cannot be equals 0, because we cannot divide by 0, and accordingly the domain is going to be from negative infinity to positive infinity besides of 0. So we write down negative infinity to 0 and positive at the 0 to positive infinity. Let's write down, it's going to be, so negative sign, is this negative? Okay, negative infinity to 0. Okay, moving over. All right, and again parenthesis, it's going to be 0 to positive infinity. Okay, checking. Fantastic. So next question, now regarding range. So range is going to be the same way. Okay, this is how the graph looks like. Okay, so it's breaking at point 0. It's the same way, and domain and range. Range is the way it's changing the y range, change of y. So y is coming from negative infinity to 0. It breaks at 0 because function doesn't have, graph doesn't have any value, and then from here, from 0 moving to positive infinity. So we are putting the same answer. It's going to be, so negative infinity 0. Okay, 0 not there, here. All right, and then moving here, and again this parenthesis, it's going to be from 0 to positive infinity. Okay, well done. Moving to next question. So what do we have? 1 over x squared. So x or x squared, it's going to be the same way because, same domain. Why? Let me see. 1 over x squared, it's going to look like this. Since x squared, so all negative numbers of x going to turn to positive. So it's going to be like this. Okay, so y is going to be only positive. Bx is positive or xb negative. So from here, domain is going to be the same way, negative infinity to positive infinity, besides of 0 because cannot be divisible by 0. So it's going to be negative infinity, and here is going to be positive infinity, and moving out. Okay, and we put the same. Okay, it's going to be from 0 to positive infinity. Okay, now we're going to do range. What is going to be range? The range is going to be value of y. So considering that we don't have any graph here in this negative part, so it's going to be from 0 to positive infinity, with the difference that 0 is not going to be included because the graph doesn't cross 0, which means it's going to be parenthesis from 0 to positive infinity. All right, moving to next question. So next we need to figure out if the function, let's say in this case 1 over x squared, it's going to be odd or even. Here is the thing. All functions that have highest degree, let's say highest degree is even. 2, 4, 6, 8, those are even. And highest degree odd, let's say it can be 3, 5, 7, and so on, 11. So if it's even, in this case we have x squared, right? Then the graph is going to be, the function is going to be even. Okay? Let me check. Okay, good job. So, and the other thing we need to know, if the function is even, then the graph is going to be symmetric with respect to y-axis, which means it's going to be either here and here, so symmetric to y, which is in this case x squared. It's going to be just like that. Or can be at the negative side. Negative side, no, it's not going to be, I'm sorry, because it's even. So y is going to be always positive. So in this case, it's going to be symmetric to y-axis. There we go. Moving question number 4. So we have 1 over x. 1 over x, that means degree is 1, right? X to power, here, x to power 1. That means it's going to be odd, correct? Now, we learned that when function is even, then the graph is going to be symmetric to y-axis. But when graph is odd, the function is odd, then the graph is going to be symmetric with respect to its origin. For example, so we have here 1 over x, right? It's going to be symmetric to its origin. Here is origin. So it's symmetric, right? Look here. Okay. So the graph function symmetric with respect to its origin. Here it is. Okay, we are solving question number 5. Identify the graph with domain negative infinity, negative 3, and negative 3, positive infinity. So negative infinity, negative 3, the domain is running based on the x-axis. So when we are talking negative 3, okay, hold on, it was positive only, okay, negative 3 only, okay. We have only negative 3, okay, this is our domain. It's going to be besides of negative 3 is not included. So let's say the graph is going like this, okay? And because in negative 3, we have a break. That's why domain cannot be, domain meaning our value of x cannot be free, okay? Which means the answer is going to be, which one? Negative 3. Let me see where it's breaking at the point of negative 3. It's going to be here. Yes, 1, the 2, 4, so every cell it's measured 2. So 2 and 4 in the middle will be 3. Okay, looks like it's this one. Negative 3. Okay, this one. All right, moving to question number 6. So we have negative infinity, positive 3, positive 3. This time it's not domain, it's range. When we have range, that means we are looking for, this was domain, yes, because we are looking at the horizontally, domain. Range is running vertically, so when we say negative 3, domain, I mean range, it's gonna go here, negative 3, which means the graph will gonna go like this and this. See, horizontal line, because it's we're talking about range. Y is equal 3, negative 3. All right, so let's find out. Positive 3. I put there negative 3, but okay, we can look for positive 3. I think it's this one. See, we have over x, there are 2 cells is going, which is 4 till the graph, and middle it's gonna be 3. We are looking on the y-axis, right? So here it is. Your y-axis here, free, and the graph is going like this and this. So from here to here, it's positive 3. Okay, and we set this A. All right. Fantastic. Moving to number 6. Now we need to find algebraically now, we need to find vertical asymptote. Vertical asymptote is the one when denominator becomes 0. Denominator here, x plus 7. Denominator is the expression that is below fractional line. So in what case it will become x plus 7 becomes 0? When x is equal negative 7, right? There. Next one. So, which graph doesn't have vertical asymptote? Not to have vertical asymptote, first of all, you have to have x squared, because x cannot be negative. So only in a case when x is negative or positive, it's gonna be vertical asymptote can be 0. Let's see. If I take x squared minus 5, first one, denominator can be 0 when x is equal what? Square root 5, right? Positive or negative square root 5. If I square it, it's going to be 5. 5 minus 5 is 0. In case of b, x can be equal 0 easily. X minus 7, when x is equal positive 7, denominator will become 0. In the case of d, denominator never becomes 0, because positive or negative you square become positive, and you have positive 5 anyway there, plus 5. So there is no way you can get 0. Therefore, this one doesn't have vertical asymptote, meaning doesn't have any break. Okay. Moving to number 9. Did I jump over? Let me see. No. We did 8. Now we are doing 9. Okay. So what we are going, how we're gonna solve this one? We need to find which one, if there is any vertical or horizontal or any oblique asymptote. So let's find out which one can have horizontal or the vertical or oblique asymptote. So vertical we already learned, it's either or here, vertical one. Horizontal when the asymptote goes horizontal, either this way. And oblique when asymptote goes like this, let's say, and graph goes like this and this. Okay, so let's see what we have here. So when I zoom it, looks like we have both. And we have 2 verticals and we have 1 horizontal, right? Verticals are running through point negative 2, positive 2x. And horizontal is running through the y is equal negative 2. Okay, let's go back and solve it. So let's identify vertical asymptote. We have 2 vertical asymptotes, right? Negative 2 and positive 2. Okay, let's solve it. So x is equal negative 2. And here it's going to be x is equal positive 2. Fantastic. Now, in the case of horizontal asymptote, we said we have a negative 2, right? So for horizontal asymptote, y is equal, because for horizontal line, it's y is equal negative 2. All right. what else we have? Domain. Domain is gonna, at the vertical asymptote, is gonna be identify domain. So to be able to figure out domain, let's say if we have, so this is our, at the vertical, -2, this is +2. We're gonna have a domain consists of three pieces. This one from -infinity till -2, since 2 cannot be included. So then it's gonna be -2, +2. +2 is not included. And from +2 to +infinity, okay? All right, so we're writing down here. It's gonna be from -infinity to -2. Okay, comma. And then another one from -2 to +2. And then comma. And then from 2 to +infinity. Oops. What is going wrong here? We have vertical asymptote is -2 and +2. Okay, then it has to go, well, it's correct. Oh, I put comma, okay, instead of a union sign, okay. This is what it's wrong. Okay. Fantastic. All right, and question, do we have, question number 11. No, 10. Okay, what do we have with question number 10? So first thing, we need to find vertical asymptote. Do we have break? If we have vertical asymptote, then graph has to have break. Since we don't have break, that means there is no vertical asymptote. Okay? All right. So I solved 10 questions, and next 10 it will come in the next recording. Okay? Okay, dokie.